All right, I want to talk about section 12.3, and the focus of this one is experimental probability. And we've been talking about what the theoretical probability of things is, but it's important to realize that experimental and theoretical are not necessarily perfectly equivalent. So we're going to take that idea of flipping a coin and getting heads, and we're going to compare the experimental with the theoretical. So we already know how to do the theoretical. And that is quite simply when we take the outcome we're looking for, in this case 1 over 2, because we're only looking for heads, and there are heads and tails available. So our probability that we expect should be 50%. But when we test, it's not always exact. And that's what we will start to notice when we're doing probability. Sorry, I dropped my marker cap. So for example, here we're going to set up a little table and we're going to test this and see how it works. I'm going to write my trial number, my trial 1. I'm going to write down, and I want to set it up how they set it up so we don't get confused. And I'll write number, and we are looking for heads, number of heads. And then I'll write number of flips. And then I'll write my experimental probability. So here I'm going to record for my trial 1. I'm going to record 10 flips. And sometimes I'll even have a little tally that I can kind of write. So I'll do that to be easy. And I'll try to flip them on screen so you can see. Heads 1, and I'm going to be going for 10 flips. 1, 2, that's another heads. Tails, 3, 4, another tails, 5, oops, that was a tails, 6, another tails, 7, 8, 9, 10. Now, to take an actual probability, I really need to do some more trials. So in this case, I should probably run trial 2, 3, and 4. And for all of these, I would probably do another 10 flips each time just to get a more accurate probability. And in fact, what I'll notice is the more trials that I do, the closer to my theoretical probability I will get to. Because if you'll notice here, if I were to calculate my experimental probability, I got 6 heads and I flipped 10 times. Now, I can compare this as a percentage to my expected percentage. This is, of course, 60%, because I know 6/10 is literally 60%. And this, I had a much higher chance of getting heads than I would normally expect. But that is to be expected when I run low amounts of trials whenever I'm doing probability. That's why when you're playing a game and you're rolling dice only occasionally, it can feel like a number comes up more often than it should. That's because it does. Because when we're looking at a small sample size, randomness does not look like we expect. I'll run one more set, and then we'll look at and see if it gets closer. Hopefully it will. It might not. Okay. 1, tails. 2, tails. 3, tails. 4, heads. Oops. 5, tails. 6, heads. 7, heads. 8, tails. 9, tails. 10, heads. Okay, so now what I can do is I can add up both of these. So this I could write as trial 1, this would be trial 1 and 2. In this case, I can add up my total amount. I have 10 total heads that I was looking for over 20 total trials because I added up both of these together. In this case, I can write this as a percentage, and I know this is exactly half, so this is 50% exactly, which is pretty lucky to get it so quickly. But what I really should do is run 2 more sets of trials of 10, and I would be very curious to see how my probabilities change as I go. I should expect to hover around 50, maybe go a little below, a little above, and then as I add in more trials, it should get as close to 50 as possible. You can run computer programs to look at this, and you can run 10,000 or millions of trials, and the longer you run trials, the more closely it approaches our theoretical expected amount. So you'll be looking at these today, and you'll be looking at the total experimental probability. I'll show you how to read one of their charts quick if you're getting a little confused. And in the first one, we'll look at the spinner landing on yellow. Spinner looks like this. We have red, green, yellow, blue. And they wrote their table very similar to mine with trial, number yellow, sum of all the total, and the experimental probability. Okay, trial 1, they had 4 and 10. Trial 2, they had 2 and 10. Trial 3, they had 3 and 10. Trial 4, they had 1 and 10. Trial 5, they had 2 and 10. And trial 6, they had 5 and 10. So in this case, if I want to find my total experimental probability, all I add up is the total favorable over my total trials. So I can really just sum up these and sum up these. 6 and 3 is 9, 10, 11, 12, 17, 20, 30, 40, 50, 60. And I can see my percentage. 17 over 60 is about 28%. I'll change this to about 28%. And my expected probability should be, well, I have yellow is 1, and I have 4 total. So my expected probability should be 1/4, or 25%. So I didn't get quite there, but it's pretty close, and that kind of is what I would expect with only this many trials. Now with a coin, there's only 2 options, so I would expect it to vary more widely. I got kind of lucky up here. The more options that I have, usually the longer it takes to get close to that expected probability. All right, I hope that makes sense, and I hope you're able to read those tables. Go ahead and good luck.